Now let's solve this exercise together. Let's begin with exercise number 1. We have that the square root of 1 plus sine theta divided by 1 minus sine theta being added to the square root of 1 minus sine theta divided by 1 plus cos sine theta is equivalent to 2 sec theta. This I believe you've tried. So let's apply rule of sorts to this. Applying the rule of sorts, we'll have this to give us 1 plus sine theta divided by root 1 minus sine theta. Applying the rule of sorts to the next, we have this will give us 1 minus sine theta divided by root 1 plus sine theta. So we are going from the left hand side to the right hand side. Okay, let's rewrite this 1 minus sine theta. Now to solve this further now, we are going to apply LCM. So let's take the LCM to give us the square root of 1 minus sine theta multiplied by the square root of 1 plus sine theta, and the numerator will be the square root of 1 plus sine theta multiplied by the square root of 1 plus sine theta. Moving on, plus the square root of 1 minus sine theta being multiplied by the square root of 1 minus sine theta. This is just simple LCM. We shouldn't let the square root be a coefficient for us. Now let's continue. Remember, we are applying the rule of sorts. The rule of sorts says that the square root of a over b is root a divided by root b, and the square root of ab is equals to root a multiplied by root b. Now let's apply that. If I apply the rule of sorts to this, we will have 1 plus sine theta multiplied by 1 plus sine theta. Everything inside the square root will be the square root of 1 plus sine theta squared. Similarly, 1 minus sine theta multiplied by the root of 1 minus sine theta will arrive at the square root of 1 minus sine theta squared, and this will result into the square root of 1 denominator minus sine theta multiplied by 1 plus sine theta. So moving on, the square root will nullify the square root for both terms of the numerator, so we'll be left with 1 plus sine theta and 1 minus sine theta. 1 plus sine theta and 1 plus 1 minus sine theta, and the denominator will be the square root of, understand that this is an expression of difference of 2 squared, so this will be 1 squared, okay, minus sine squared theta, or we can just simply say 1 minus sine squared theta. Now we can see now that the denominator or the numerator is an expression of 2, because sine theta will nullify minus sine theta and be left with 2 divided by the square root of 1 minus sine squared theta. For us to understand that vividly, we go back to the first expression of trig identities that says sine squared theta is a plus cos squared theta is equals to 1. So with that, we have that 1 minus sine squared theta, that's an expression of cos theta. 1 cos squared theta is 1 minus sine squared theta. So applying this principle now to this, we will have this denominator to give us the square root of cos squared theta, and the square root of cos squared theta is equals to cos theta, so divided by cos theta, and this is 2 multiplied by 1 over cos theta. 1 over cos theta is the reciprocal trigonometric function, which is equivalent to sec theta. So we have derived this because 2 sec theta is the right hand side, what we have here. Now let's proceed further as we take the second question. So let's take this and duplicate it into the new page. Now tan square theta minus sine square theta is equals to equivalent to sine raised to the power 4 theta sec squared theta. As usual, we'll go from the left hand side to the right hand side. Now let's write the expressions of tan theta and sec squared theta so that we will not make mistakes. So to do this now, we'll write that cosec, okay, cosec squared theta or cosec theta is 1 over sine theta, sec theta is 1 over cos theta, cot theta is 1 over tan theta, and tan theta is equals to sine theta divided by cos theta. So let's make our substitution. We will substitute tan theta, which is sine theta, over cos theta. We will have this to give us sine theta divided by cos theta squared minus sine squared theta. So equating these terms together now, we'll have sine squared theta divided by cos squared theta minus sine squared theta. Moving on, we can write this as an reciprocal function, that sine squared theta multiplied by 1 over cos squared theta rather, minus sine squared theta. Now if you look at this closely, 1 over cos theta is equals to sec squared theta, is equals to sec theta, and 1 over cos squared theta will be equals to sec squared theta. So let's change our ink to black, and we'll have here that 1 over cos squared theta is equals to sec squared theta. So we'll have sine squared theta multiplied by sec squared theta minus sine squared theta. Now we can factorize using sine squared theta, and sine squared theta will give us as a factor of sec squared theta minus 1. Now let's recall again the 3 trigonometric functions or identities, which will lead us to the next slave, and that will be cos squared theta plus sine squared theta is equals to 1. Dividing all through by cos, we'll have 1 plus tan squared theta is equals to sec squared theta. Divided all through by sine, we'll have cot squared theta plus 1 is equals to cosec squared theta. So now we want to find an expression that contains sec squared theta, and that is equation 2. So let's make sec squared theta subject of formula, or sec squared theta minus 1 subject of formula. So that means tan squared theta from the second expression, we can see that tan squared theta, okay, making tan squared theta subject of formula, we will have it to be equals to sec squared theta minus 1. So if you compare, we will have sec squared theta minus 1, and we also have sec squared theta minus 1, which is equals to tan squared theta. So we can convert this and substitute it. Changing our ink to black, remember we are going to sine squared theta divided sine raised to the power 4 theta multiplied by sec squared theta. So let's substitute this now. We will have sine squared theta multiplied by tan squared theta. Now we recall from here that our tan theta is equals to sine theta divided by cos theta. So let's make our substitution. So this will be sine squared theta multiplied by sine squared theta divided by cos squared theta, because tan theta is equals to sine divided by cos. Then moving on, the numerator will simply be sine raised to the power of 4 theta according to indices, and the denominator will be 1 over cos squared theta. Now just like we did earlier, that 1 over cos squared theta is equals to sec squared theta. So we do the same thing here, and we will arrive at the final expression of sine raised to the power of 4 theta sec squared theta, which is the right hand side. So we have derived the expression that tan square theta divided minus tan square theta minus sine square theta is equals to sine raised to the power of 4 theta sec square theta. So we can see now that all we used in trigonometric identities simplification is the three trigonometric fundamentals and the reciprocal functions.